express this as a diagonal bigeometric. But this one, let's see how can we express this term as in a matrix. So it's going to be a little bit cumbersome. So I'm going to use both what I have in there and try to derive it here. So let's first consider these two terms. So what do you get for that? The divergence of E times the electric field plus E goes with the gradient times the electric field. So in this one, you get what? dEx by dx plus dEy by dy plus dEz by dz times the electric field. So that's going to be dx x plus dy y plus ez z. So that's the first term, and for the second term, what do you get? And as this is going to be, first you have to do this one. So that would give you Ex d by dx plus Ey d by dy plus Ez d by dz of Ex x hat plus Ey y hat plus Ez d hat. Now, first let's look at the components along the unit vector x. So if we just collect the components along the unit vector x, just consider, this with that and this with that. So what do you get? So this is going to be just only for the x component. I'm going to do it just only for the x component. So you have Ex dEx by dx from this term. We're just considering this and that, this and that. So you would have plus Ex times dE. Ex dEx by dx. So that's what we get from the first step, right? So this is going to be x hat. Another x component is when you take this with that, right? So this one with this one, and this one with this one. So what do you get? You get plus Ex dEy with respect to y Ex plus Ey dEx with respect to y along x hat. And the other x component is when you take this with this, right? And this with this. You agree? So what do you get? You have one other term. That's gonna be dEz by dz ex plus that one. That's gonna be dz dEx by dz x hat. All right. So you would have similar expressions for y and z. All right. So I'll just put a dot here. And all right. So what do you see here? Can you write this as one term? So this is, if you apply the product rule, this is gonna be the same as d by dx of ex along x hat plus, and this is gonna be d by dy of ex ey x hat plus d by dz of ex ez along z hat. All right. Now, based on that, who can tell me what's coming from this term? From the next, just applying the same here. So here, what should I have? D by dx of ey ex, right? So I would write it as ex ey x hat plus d by dy of ey y hat plus x hat, this is x hat, and this is y hat, right? It should be y hat plus d by dz of ey ez y hat. All right. So similarly, for the z component, plus d by dz of, I should have here what? dx ez on y x z hat plus d by dy of ey ez of z hat plus d by dz of ez along z hat.
The last row, the first differential.
X, yes, thank you. All right, now just let's consider this and this and this. So in other words, just only as a sum of vectors that has components x, y, z. So if I write these three first, and then this second, and that third, I would have d by dx of ex x hat. So I'm considering this plus